How to add hexadecimal numbers. In this tutorial, we will describe how to add hexadecimal numbers. In the Terms Involved in Math Operations video, we discussed terms involved in addition. Since we will be adding hexadecimal numbers, the operands involved in addition are origin and add-in. The results would be the sum. For example, let us add the following. Okay, so we're going to apply an addition here, and as we mentioned, the terms involved is origin and add-in, which will produce a sum. For this example, and of course it's represented in decimal base, is the value 44,639, and we're going to add the value 6,956, and our expected value should be 51,595. So over to the right, we have a hexadecimal representation of these numbers. So 44,639 is represented as AE5F, and the value 6,956 is represented as 1B2C. I have some notes up to the top. If you look at the top right, we got A is 10. B is 11, C is 12, D is 13, E is 14, and F is 15. This is because we're dealing with the hexadecimal base. So we start off just like we did with the decimal base numbers from 0 to 9. But when we get to 10, we start using letters. So that's why we have A through F. If you look towards the left, you'll see I also have some notes. The values 16 to the 0 power is 1, 16 to the first power is 16, 16 to the second power is 256, 16 to the third power is 4,096. All of this is going to become helpful, so let's see what we have. Alright, so what I want to do, let's go ahead and add up the right column just as we did in our previous videos with binary addition. So we can see what we have. Alright, so we're going to add F to C. And in hexadecimal, an F is represented as 15. And C is the value 12. So this is same as saying 27. But we can't have two digits in a column. So what we do is we can only have one digit. So what we do here is subtract 16 from 27. And that leaves 11. Now the 16 here is going to represent the carry. And so we have a carry over to the next significant column. And the value 11 is represented as B in hexadecimal. So we put B right here. Alright, so let's add up the next significant column. We have 2, 5, and 1. That's a value of 8. Alright, let's add up the next significant column. So this time we're going to add E and B. And that's the same as adding 14 and 11. And when we add it up, we get 25. And once again, you can't have two digits in a column. So let's go ahead and subtract 16 from this. And that gives us 25 minus 16 equals, oops, let's undo that. Okay, so it gives us a value 9. And once again, the 16 is going to be a carry. It represents 1. So 1 goes here, and for this particular column, the value 9 goes here. And so we go to the next column to add up. We have 1, A, and 1. And we say that A is the value 10. So when you add 2 to 10, you get the value 12. but 12 in hexadecimal is represented with the value C. And this is our sum. So now let's check to see if the value C98B is the decimal equivalent of 51,595. So as we had to the left, I show you the positions. This is the 0th position, this is the first position, this is the second position, this is the third position. So what we could do is to show how to convert, so we have C times 16 to the third power plus 9 times 16 to the second power plus 8 times 16 to the first power plus B times 16 to the 0 power. All right, so this is also the same as saying 12, because C in hexadecimal represents 12 times 16 to the third power. And of course we have 9 times 16 to the second power. And then we have 8 times 16 to the first power. And B is the same as having times 16 to the 0 power. And let's see what we have. So we have 16 to the third power is 4,096 times 12. And that's a value of 49,152. Plus 9 times 16 to the second power, so that's the same thing as 256 times 9. It's a value of 2304. And then we have 16 times 8 is 128. And then we have 11 times 1 is 11. And so when you add it up, we have, see, 49,152 plus 2304 plus 128 plus 11. And it comes out to be a value of 51,595. And this is what we wanted to show. Next, let us perform another hexadecimal addition. This time we will add numbers with a decimal point. Okay, so once again we have addition, and start off with our origin and add-in. So the origin this time is 44,450.25, and the add-in is the value is 6,920.25. And our sum will be 51,370.50. This is our expected value. For the value of 44,450.25, its hexadecimal representation is ADA2.4. For the value 6,920.25, our representation is 1B08.4. So we will go ahead and add up as we normally do. We start from the right column. This time we have a decimal point, so I'm just going to try to keep it aligned. So our decimal point goes here. All right, so the right column, this is the least significant. So we add 4 plus 4, we get 8. And then we go to the next significant column, which would be here, and 8 plus 2 is 10. But we say that in hexadecimal, the value 10 is represented with the letter A. So A goes here. And we go add the next significant column. We have A and 0. That's also A. And then we have the next significant column, which is D and B. So D is the same as 13, and then B is the same as 11. So when we add it up, we have 24. You can't have two digits in a column. So what we're going to do is just subtract out 16 here. And let's see, it's 24 minus 16. That's a value of 8. And we said that this 16 here is really our carry, so that represents 1. So in the previous column, 1 goes here, and the 8 goes here. So in the next significant column, we have 1 plus A plus 1 is a value of 12, and that's represented as C in hexadecimal. And so this is the sum. So now let's show to see if this value comes out to be 51,370.50. Okay, so let's move this over here. So it's the same as saying, so we have C times 16 to the third power, because we say this is the third position, second, first. This is the 0th position. This is the -1 position because it's to the right of the decimal point. So we have C times 16 to the third power plus 8 times 16 to the second power, and we have A times 16 to the first power, and we have A times 16 to the 0 power, and we have 8 times 16 to the -1 power. Okay, so this is the same as saying 12 times 16 to the third power, and 8 times 16 to the second power, plus 10 times 16 to the first power, and the same as 10 times 16 to the 0th power. And then we got same thing, 8 times 16 to the -1 power. All right, so this is 12 times 4,096, same as times 12. So we have a value of 49,152. And then we have 256 times 8 is a value of 2,048. And then we have 10 times 16 is really 160. And then we have 10 times 1 is 10. And also, when we have 16 to the -1 power, that's 1 over 16. And that's the same as 1 divided by 16 is a value of, it's 0.0625. When you multiply this times 8, we get the value, it's 0.50. And that's what this is right here. So 0.50. So when we add it up, we get the value. Let's add it up. So we have 49,152 plus 2,048 plus 160 plus 10 plus 0.5. And just as we say it here, it's the value 51,370.5. And that's what we wanted to show. This puts us in a position for my next tutorial, where we will describe the subtraction of hexadecimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.